Hello learners, this is education online program. Our subject is chemistry and I'm teacher Lily. So we are going to go through the topic on physical properties of period 3 in a periodic table. So one of them is the ionization energy. So here we are going to see that the period 3 has 8 elements, and we remember them as we go from sodium to argon. So as we move from left to right of the periodic table, then we call this as the period. So it is a row in a periodic table. And as we call a group is a column in a periodic table. So we want to know the ionization energy across the period from left to right. So it means from sodium to argon, that is in period 3. So what is this ionization energy? First of all, we need to know that ionization energy is the energy required to remove an electron from a gaseous atom. Is the energy required to remove an electron from a gaseous atom. So ionization energy of period 3 elements generally shows an increase moving across the period. So as you move from sodium to argon, you'll see that there is increase in the ionization energy. So at the left side of the periodic table, you will have that the ionization energy is low compared to the right hand side of the periodic table. It means as you move from sodium has the lowest ionization energy compared to the rest of the elements in period 3. So we need to put this one down, and we say that ionization energy. So we have ionization energy which is denoted as IE. Said IE, it means we are meaning ionization energy. So ionization energy is the energy required to remove one gaseous atom. Is the energy required to remove an electron from a gaseous atom. So if you said ionization energy is the energy required to remove an electron from a gaseous atom. So if we remove an electron, it means we are showing what is known as the ionization energy. It means it needs an ionization energy in order for you to upload the electrons from any gaseous atom. So here ionization energy in period 3 generally shows an increase as you move across the period from left to right. So we have to remember that ionization energy increase from left to right of the periodic table that is in period 3, specifically in period 3. So we have in period 3 the ionization energy increases from left to right. So in this case we need to remember that sodium has the lowest ionization energy, and as we move from sodium and then we go to magnesium, so here magnesium has the lowest energy compared to aluminium, and aluminium has the lowest energy compared to phosphorus, compared to silicon, because we have silicon in group 4, and then we have phosphorus, then we have sulfur, and we have chlorine, then lastly we have argon. So as we move from sodium to argon, the ionization energy increases. So the atom here, or the element here, that has the lowest ionization energy is sodium. So sodium with the symbol Na has the lowest ionization energy in period 3. So here we have to see that as we move from left to right, sodium is having the lowest ionization energy compared to the rest of the element in group 3. So learners, we need to remember that the ionization energy is the energy required to remove an electron from a gaseous atom. So also you need to remember that ionization energy increases from left to right in period 3. So here we mean that from sodium to argon. So it means from sodium to argon, and the lowest element here that has the lowest ionization energy is sodium, and the one with the highest ionization energy as we move to the left is chlorine. So here, why can't we say argon? Because argon is an inert gas, and we know that inert gas has a complete outermost cell, so they neither lose nor gain electrons. So the one with the highest ionization energy is chlorine at the left side of period, at the right hand side of period 3. So here we need to remember, however, there are exceptions on or interruption in the middle of the trend. So it's as we move from left to right, as it is a rule, we say that as we move from left to right, there is increase in the ionization energy. But due to some exceptions, we shall have that there is interruption in the middle of this period as we move from sodium to argon. So it means these interruptions are going to be brought out with some other factors. So we need to remember that here ionization energy, however, ionization energy changes in the middle of the period 3. So we have seen that the aluminium, we have the elements, and we have ionization energy. So the unit for ionization energy is kilojoules per moles. The unit for ionization energy value is kilojoules per moles. So here we have to put the unit, which is kilojoules per moles. So here we put the element sodium having 496, magnesium with 740. So aluminium, we have seen that in aluminium there is 584. Silicon has 793, while phosphorus has 1017. So we have seen that there is drop wear in aluminium, and also we have seen that from aluminium it increases a bit to 793. So phosphorus will have 1017, while sulfur has 1006. Chlorine has 1257. So the last element, which is argon, so argon has 10,520. So we have seen here that there is decrease in sulfur and there is also decrease in aluminium. So that is what I was explaining before, that there are irregularities in the middle of period 3. So aluminium with the smallest with the drop in ionization energy, also sulfur experience a drop in ionization energy. But generally we need to remember that ionization energy increases from left to right. So what happened in the middle is an exceptional interruptions. So the few irregularities in general trends are related to the extra instabilities shown by sub-energy levels that are either empty or half cell. So this drop here in aluminium, the drop in ionization energy of aluminium and sulfur is brought about, this is was brought about due to extra stability shown by sub shells, sub energy levels that are either empty or half filled. Empty or half filled. So this drop in aluminium and phosphorus is brought about due to the extra stability. There is extra stability shown by what? Shown by sub energy levels, which is either empty or half filled shells. So you may find that the energy levels is half filled in aluminium or in sulfur. That make them to have a drop in the ionization energy. So learners, you need to remember that the drop in between the ionization energy of period 3 is brought about the extra stability, which is shown is in either empty shells or half shells of the energy level in each element, which is aluminium or sulfur. That is why you have a drop. We have a drop in the ionization energy due to the following two reasons, which is either empty half cell, or we need to remember that these are the shells whereby any cell should occupy a number of electrons, which is pair of electrons. So it means that energy level or that subshell, which is known as the orbitals, is either empty or it is half cell. So we need to remember that a half subcell, for example S, and it may have a single electron, which is not a rule, but it should have two electrons. So it means that a pair of electrons in the orbital S. So if this S occupies only a single electron, or if it doesn't have an electron or it has been removed out, then it will cause a drop in aluminium or in sulfur ionization energy. So also we need to remember that this is the case with aluminium having lower fast ionization energy than magnesium. So we remember here that ionization energy for aluminium should be higher than the one of magnesium. This is how we take it, as we said in general, that ionization energy changes. Ionization energy increases from left to right of period 3, but as we reach to aluminium it drops, which is an interruption that you may find that it's a surprise. So here, why does it happen like that? This is because here we have the ionization energy of magnesium is taken from the first energy level of magnesium. But for aluminium, which is having 3 electrons in the outermost cells, it is the second energy level that the ionization energy is taken from. So in this case, we have a drop in the ionization energy. So we need to put this one down, and you remember that the ionization energy is the energy required to remove a single electron from a gaseous atoms. So it increases from left to right of the periodic table, but with a few interruptions in the middle of the periodic table in period 3. So here this is say that aluminium having lower ionization energy, having lower ionization energy, having low ionization energy compared to than magnesium. So we have seen there that magnesium has the highest ionization energy compared to aluminium. So this is because the first ionization energy is affected by a number of factors. This is because the first ionization energy is affected by a number of factors. So here the first factor here is the charge in the nucleus. So the charge in the nucleus is responsible for the drop in the ionization energy of aluminium, which is now lower than magnesium. So the charge is responsible for this drop, the charge in the nucleus. Also, number 2, we have the distance of the outermost electrons from the nucleus. The distance of the outermost electrons from the nucleus. The distance of the outermost electrons from the nucleus, and also the amount of screening by inner electrons. So with these few factors that affects the ionization energy of aluminium or sulfur, here we are going to say that the factors are the charge in the nucleus is one of the factors that affect the ionization energy or interrupt the regular ionization energy of period 3. So also the distance of the outermost electrons from the nucleus. Also this causes the drop in the ionization energy in the middle of period 3. So also we have the amount of screening by inner electrons. So here you may find that the electrons which are nearer to the nucleus, they cause what is known as screening. So it covers the nucleus, and the electrons which are far from the nucleus may not have the effect of the nucleus or the pulling of the nucleus of the electrons towards the nucleus. We have also the last factor is whether the electron is alone in a sub energy level or in pair. So also we need to remember what I've said there. We have number 4 is that the number of electrons in a sub shell. So this can be either empty subshell, empty subshell, or half filled. So if the subshell is half filled or it has a single electron, it will also affect the ionization energy of the period 3, which is in the middle, which is aluminium and sulfur, which are mostly affected with these factors. So you need to remember that the factors that affect the ionization energy of period 3 is the charge in the nucleus. The distance of the outermost electrons from the nucleus also causes the drop in the ionization energy. The amount of screening by inner electrons also affect the ionization energy. And lastly, the number of electrons in a subcell. So any subcell should have a filled up electrons in each subshell. So if it is half or it is empty, then it will affect the ionization energy of period 3. That is why it has been experienced in the middle that aluminium and sulfur, they have a drop in their ionization energy. So we need also to know that the fall of aluminium and sulfur, it has expected that aluminium with the extra protons than magnesium should have a higher ionization energy. So we know that according to the rule here that the ionization energy increases from left to right. So we expect that aluminium and magnesium, magnesium should have the lowest ionization energy compared to aluminium, but in this case this is not true. So here this fall in ionization energy shows that aluminium with an extra electron than magnesium should have a higher value of ionization energy. Though this is not the case, the electrons to be lost in aluminium is located in the second subshell. So by explaining that magnesium should have higher ionization energy compared to aluminium, this is brought about because in aluminium is located, the electrons which are going to be lost in aluminium are those ones located in the second subshells. So here, which is slightly far from the nucleus. So the subshells is the one determining the loss of electrons. So here, for ionization energy of aluminium, the electrons are far from the nucleus, and those electrons are the one going to be lost. So in this case, it is far from the nucleus. So this is explaining that the distance of the outermost electrons from the nucleus, and also the amount of screening by the inner electrons. So this causes that there is lowering of ionization energy in magnesium and aluminium. So this, we have also aluminium electrons to be lost in the second subshell energy, which is far from the nucleus. So magnesium is in the first subshell. So because magnesium has their electrons which are going to be lost in the first subshell, so they are nearer to the nucleus compared to the one of aluminium, which is in the second subshell. So the electrons in the second subshell of aluminium are the one going to participate in formation of the ions or the compounds. So phosphorus to sulfur. So we have seen that also there is a drop in sulfur. So phosphorus to sulfur, we have to know that sulfur is the first element before sulfur. Phosphorus is the first element before sulfur. So here, suppose sulfur has to have the lowest ionization energy. The phosphorus has to have the lowest ionization energy compared to the one of sulfur. But now the opposite is true. So we have seen that sulfur has the lowest ionization energy compared to phosphorus. So the screening is identical in both phosphorus and sulfur, and the electrons to be lost are in the same subshell. So although the electrons are all in the same subshell, but still there is difference that the sulfur electrons to be lost has pair with another. So we need to remember that with the sulfur, With the sulfur, it forms 8 atoms. So a structure of a sulfur molecules, it has 8 more sulfur atoms that are binding together to form a concrete structure. So this makes it to have has paired with another atom. So it means sulfur has been paired to another sulfur. So we shall say that a sulfur connected to another sulfur. So uh, this make it to have a pair electrons, and this causes the lowering of electrons of ionization energy in sulfur compared to the one of phosphorus. So here the pairing between the two electrons increases repulsion, making it easier to remove an electron in sulfur than it would have been predicted. So it is much easier to remove electrons in sulfur due to the screening of the nucleus. So with these learners, we know that now these electrons, this ionization energy in aluminium and in sulfur, it is caused due to very important factors, which we have already seen here, that the charge in the nucleus, the distance of the outermost electrons from the nucleus, the amount of screening by the inner electrons, and lastly the number of electrons in the subshell. So you may find that the subshell is either empty or half filled. So this causes the decrease in the ionization energy. So also we need to know that valences, so the number of electrons to be lost or gained when when an element react determine the valency of the element. So if you say the valency of the element is the number of the electrons, so we need to remember that this ionization energy is very important when we are dealing with the formation of compound. So we need to remember the factors that affect the ionization energies, and also we need to remember the values of each ionization energy and which elements in period 3 that has a lower ionization energy than it should have been. So with these learners, we have come to the end of this the properties of period 3, which is ionization energy. So till we meet next time, and we shall continue with the properties of the period 3. Thank you.